Well, greetings. So here we are trying to make a full day out of a partial day. So grab your packets and a pencil and let's go to it. Remember that if I'm going too quickly or if you need a little bit of time to process, just go ahead and shut this thing off or pause it and compose yourself and get what you need and come back. So we're going to be on page 9. And this is day 2 of imaginary numbers. We're going to do a little bit of graphing, a little bit of simplifying, and so here we go. So we're going to start out with graphing imaginary numbers and absolute value, and you can use what we call the complex number plane in order to represent a complex number geometrically. And we're going to really set up 2 axes. Your x-axis will be your real axis, and your y-axis will be your imaginary axis. And things are actually pretty easy to graph. All you've got to do, say for example, to graph this right here, 3 minus 4i, you would graph this the same way as you would graph 3 negative 4. So you would go 3 in the real direction because that is your real portion, and then down 4, 1, 2, 3, 4 in your imaginary direction. And you would plot the point right there, and that represents 3 minus 4i, because if you actually look at the geometry of it, well, if you look at the horizontal, that's going to be 3 in that direction, in the real direction, and in the vertical, which is your imaginary direction, you'll go down 4. So that will be representing negative 4i. And a lot of times they'll go ahead and draw a broken line from the origin to the point. Kind of helps a little bit if you have a ruler, but with my setup it's going to be a little awkward, but you get the idea. So you get a right triangle out of this thing. And if you look at this, this is going to be like a 3, 4. Wouldn't that length be 5? Because it is a right triangle, and this would be one of the Pythagorean triples. So we can actually use that to get the distance from the origin on the complex number plane to this point that we put here. And we're just going to go ahead and use the absolute value of the complex number, which is the distance from the origin on the complex number plane. You can find it by using the Pythagorean theorem. So in general, a plus bi equals, if we call this a, and this b, it would be a squared plus b squared equals this particular length. It's as easy as that. So if we go ahead and use this, and this will be the formula that we're interested in, and you notice that there's no imaginary part with the b, because a distance is a real number. It's an actual number. So we can't put an I in here because that's imaginary. It's not real. So if we look at this, we can go ahead and just say that a is 0 because there is no real part, and b is just the coefficient on the imaginary part. That's going to be 5. So the absolute value of 5i is just going to be the square root of 0 squared plus 5 squared, which is the square root of 25, which is 5, right? And that makes sense. 3, 4, 5. So if we want to find the absolute value then of 3 minus 4i, a would be 3, b would be negative 4. So the absolute value of that, 3 minus 4i, is the square root of a squared I'm sorry, back that up. We can actually put the numbers in here. So undo, undo, undo. Square root of 3 squared plus negative 4 squared. Well, that's just going to be the square root of 9 plus 16, which is the square root of 25, which again is going to be 5. All right, so there that is. It's really no harder than what you see right here. Okay, so now we're going to go ahead and simplify some of these things, and I actually have on my notes doing these on a separate sheet of paper because this isn't a whole lot of room. It's way more room than we had last year, but this can get kind of busy. But I'm just going to see if I can't fit it in here. Hopefully I can. So be careful, this is not squaring this. This is cubing it. That means to use this as a factor 3 times. So what I'm just going to do is start out by using it twice, getting a complex number out of that, a product, and then using that with the third factor of 2 plus I and getting a final answer. So 2 plus I times 2 plus I. And this is just going to be foiling. So 2 times 2 is 4, 2 times I is plus 2I, and then plus another 2I, and then plus I squared, right? But isn't plus I squared the same as negative 1? So plus I squared, remember it comes up all the time? So 4 plus, it's not a plus sign, get rid of that. 4 plus 4I minus 1, that would be 3 plus 4I. And that's kind of part the way there. We're just going to go ahead and now do that, use that as a factor with the third factor of 2 plus I. So here's 1, here's 2, here's 3. We're actually cubing it because this represents 2 plus I squared. All right, so let's FOIL that one. 2 times 3 is 6. 2 times 4I is plus 8I. I times 3 is plus 3I. And I times 4 is 4I squared, which is minus 4. So our final answer here will be 2 plus 11I. Got that one taken care of. So yeah, so there we go with that. Okay, so on this one here, number 2, I'm kind of going to do this in 2 parts also. The 2 plus 3I squared, I'm just going to go ahead and square that, and then I'm going to divide by 3 minus 4I, which will involve a conjugate, if you remember what we did on Friday. So 2 plus 3I times 2 plus 3I. In fact, I mean, you can write this, you know, as one thing if you want, over 3 minus 4I. And I'll just go ahead and take care of this numerator. So 2 times 2 is 4. And then 2 times 3I is 6I. Plus 3I times 2 is another 6I. So that's plus 12I. And then 3I times 3I is plus 9I squared, which is minus 9. And that's going to be all over 3 minus 4I. So let's go back over here. That's going to be negative 5 plus 12I divided by 3 minus 4I. All right, now it's the division part. So we're just going to go ahead and we're going to multiply by the conjugate of this 3 minus 4I, which would be 3 plus 4I over itself. Okay? And so you're going to get a denominator, and I'm not going to do all 4 of the products when I multiply this to this. I'm just going to do the outsides, which would be 9, and the insides, which would be what? Minus 16I squared, which is plus 16. All right, so if you need to process that, you can go ahead and pause. Get that looking a little nicer here. So plus 16. All right, now we can FOIL this to this. And that's going to be a lot more complicated because it won't have the middle term go to 0 like it did when we were doing the denominator. So negative 5 times 3 is negative 15. That will be a minus 20i. And then 12 times 3 is plus 36i. Extend that out a little bit. And then a 12i times 4i is a plus 48i squared, but that's going to be a minus 48. All right? So let's put this all together. And the denominator should be 25. We have a negative 15. Nothing will combine. Oh, wait. Negative 48 will combine with it. So you just add the numbers and keep the signs. So negative 15 plus a negative 48. That'll be a negative 3, carry the 1, a negative 63. All right, so that'll be a negative 63. And 36 minus 20 is plus 16i. So that's that. All right, so we kind of did the multiplication first, and then we rationalized the denominator second, and you can look to see if that'll simplify anymore. It's not going to, because you don't have a common factor with this term, and this term, so done. Very much done. All right, so rolling along here, we'll go down to number 3, and this is not written in a convenient way for, we don't have anything written with i's or anything written as an imaginary, so let's do that first. So this will be 3 plus, that would be 6i, parentheses are optional, and divided by, all right, we got to think about this one a little bit. All right, so looks like we're missing a, we're missing some parentheses here. 2 to the 5th, I believe, is 32. So that's actually going to be, since you're raising a negative to that quantity, to an odd number quantity, that will still be negative. So this is the opposite of the square root of negative 32. So that'll bear a little simplifying. So this will be 3 plus 6i, which is kind of drag that along with us. And this is the opposite of, and let's kind of factor this out. You have a negative 1, and then a 16, and then a 2, right? So 16 times 2 is 32. All right, so that's going to come out as I. All right, so this will be 3 plus 6i. You still have this negative sign here. This comes out as I. 16 comes out as 4, so that'll be negative 4i square root 2. All right, so we're going to have to rationalize that denominator, and we have 2 radicals here. I is a radical, radical 2 is a radical. So we're going to go ahead, we won't worry so much about the negative 4, and we're going to multiply by I square root 2 over itself. Let's see what we get. Okay, in the denominator, this will be negative 4 still. And I times I is I squared, which is negative. So if that's just negative 1, that will go positive. And then radical 2 times radical 2 is just 2. So that's just going to be 4 times 2. And we'll just carry this down here. That'll be 8. And then your numerator, that'll be 3i root 2. That's just going to be this distributed to here. And then that'll be 6i squared root 2, positive 6i squared root 2. So won't that end up being minus 6 root 2? Because the I squared just goes to negative 1, and that's why it went from positive to negative. So I think this may actually be done. So I'm going to put this in order, and this is the real part, like the A part. So that will be negative 6 square root 2 plus 3i square root 2. And resist the urge to factor out the root 2. There really isn't any need to do that. So there's your third one. And yeah, these are interesting. So let's go to your fourth one here. And this may seem like, okay, what do I do with this 8? Well, you got to make this whole thing, this term and this term, into one fraction. So what I'm going to do is I'm going to take this 8 over 1 and I'm going to multiply it by 1 plus 2i. So 1 plus 2i over 1 plus 2i. And that will give me a common denominator. So you'll distribute the 8 over. That'll be 8 plus 16i plus 4 minus I over, and now you just have a common denominator of 1 plus 2i. Do you see how I did that? Right, all of this became these first two terms here. And here's your other two terms, and here's your common denominator. So let's see what we can put together. 8 plus 4, that's 12. 16i minus I is plus 15i, and that'll be over 1 plus 2i. All right? And that means that we are going to have to rationalize that denominator, because no i's allowed in the denominator, no radicals in a denominator. So conjugate for that will be 1 minus 2i over itself. And remember that when you have conjugates, you only have to multiply the two firsts and the two lasts. So that should take care of your radicals. So 1 times 1 is 1, and plus 2i times a negative 2i is a negative 4i squared, which is plus 4, right? So that'll become a 5. And now let's do your numerator. 1 times 12 is 12. Let's see, 12 times negative 2i is negative 24i. 15i times 1 is plus 15i. And then 15i times negative 2i is negative 30i squared, which I think is plus 30. All right, ran out of room a little bit. So 42, if you add the 30 and the 12, and then a negative 24 plus 15, isn't that going to be minus 9i? And let's make sure I did that right. Okay, I'm going to pause for a second just to double check my work. So hang on. All right, I'm back. And guess what? This is right. Never doubt yourself, but always kind of look back and make sure, you know, that you're comfortable with your answer. So again, I'm going to pause one more time because I've got to go to a new sheet. It will only seem like a second in your time. All right, so I'm back. Told you it wouldn't take long. This is the last major example. So I guess I'm going to square what I have in the denominator. So that means to write it twice and FOIL it. So 3 plus I times 3 plus I. And that'll be 1 over, let's see, 3 times 3 is 9. And you can't just do the first and the last because you don't have a plus and a minus. You have both pluses. So 9 plus 3i plus 3i plus I squared. Well, plus I squared is just going to be minus 1. So that'll be 1 over 9 minus 1 is 8 plus 6i squared. All right? So from here, we're going to have to rationalize that denominator. So we'll just get the conjugate. Ooh, hang on. Let me just make sure. I want to fix this. That would be plus 6i. I'm sorry, not 6i squared. Good thing I caught that. So conjugate here would be 8 minus 6i over itself That's kind of convenient for your numerator, so that'll just be 8 plus 6i in the numerator. In the denominator, that will be 8 times 8 is 64, and this will be minus 36i squared, which is plus 36. All right, and that looks like, if we put it all together, 8 plus 6i over 100. And do you notice that everything here, the 8, the 6, and the 100, is divisible by 2? So you can take a 2 out. Just reduce a 2. So reduce, reduce, reduce. And I'll get 4 plus 3i over 50. And you are expected to reduce those. So please do so. Let's get that looking a little nicer. Don't want to wreck the answer after all that work. All right, so that's the major part of this. Let's go on to this. It should not take very long. We're almost there. So you remember that when you're multiplying two binomials that are exactly the same, except one is minus and one is plus, that is kind of like a difference of squares. And you only get a two-term answer. So this will be a squared minus b squared. Remember factoring this back to this, that sort of thing? All right, so this is going to be a similar approach here. We're just going to have to multiply these two together, multiply these two together, and it ends up being negative in between. So this is going to be a squared minus b times I squared, right? It's pretty much the same as these two things, except you have the I. So that'll be a squared minus b squared times I squared. And remember, I squared is -1, so that'll change this negative to a positive. So it's a squared plus b squared. So now, although we usually factor over the set of real numbers, you can see that this can factor, you know, back to this. But please don't. Please don't. The instructions on factoring drills are to keep it over the set of integers, and we're assuming real numbers. So yeah, so looking at this, this is just going to be, it says factor each of these. This is just going to be y plus I times y minus I. And if you remultiply that, you're just going to multiply these two things together. Y times y is y squared. And don't do the inside and the outside. It just goes to 0 anyway. But it'll be minus I squared, which is -1. Negative turns that to positive. So you go back to y squared plus 1. See? So it's going to be that way for all of these. A plus 2i times a minus 2i. All right? Over here, this will be x plus 5i, x minus 5i. So you can see that if this thing is equal to 0, we can figure out imaginary roots. All right? So we'll finish up with these last 5 examples, and then we'll be through. All right, so this will be y plus 3i if we're solving it by factoring. Y minus 3i equals 0. So the zero product property says that y plus 3i has to equal 0, or y minus 3i has to equal 0. So y equals 3i, I'm sorry, I guess that would be negative here, 3i. Y equals positive 3i. Oops, I was thinking plus minus because that's how I'm going to report it at the end. Or y equals plus or minus 3i. Remember conjugate pairs? You're looking at them. Same thing over here. X plus 11i times x minus 11i, get that right, equals 0. And without going through all of the, well, I guess we will. So x plus 11i equals 0, or x minus 11i equals 0. So x is plus or minus 11i. And so it goes. Now this one here is a little bit more standard. Y plus 4 times y minus 4 equals 0. So this is there's no imaginary portion of this, so y is plus or minus 4. And we'll just do the same thing here. All right, this is going to be a plus I square root 17, right? That is the only way to factor a 17 evenly. And then a minus I square root 17 equals 0. So you can set them each factor equal to 0. A plus I square root 17 equals 0, or a minus I square root 17 equals 0. So a equals plus or minus I root 17. This one here, keep in mind that we need for this to equal 0. This whole process, everything here, everything is set equal to 0. So we need to set this equal to 0 too. So just add 5 back. So x squared plus 25 equals 0. And you can factor that. X plus 5i times x minus 5i equals 0. And x is going to be plus or minus 5i. So there it is. I won't take up any more of your time, but if you need anything more, just either bring your questions to class or rewatch the video. So thanks for your attention, and I appreciate that you did this. See you next time.